Lesson A3 notes, geometric mean and hills in SAAS, right triangle proportions. A geometric mean is a special proportion where the means are the same. So in Unit 7, we talked about the extremes and the mean. So here is the extreme over the mean is equal to the mean over the extreme. If a, b, and x are positive numbers, and a over x is equal to x over b, then x is called the geometric mean between a and b. Now, if you were to solve the proportion, so we have x times x, so that's x squared. That is equal to a times b, which is just ab. I want to take the square root on both sides to get x by itself, so x is equal to plus or minus the square root of ab. So, if you solve the proportion for x by taking the square root on both sides, you will see that x is equal to plus or minus the square root of AB. However, the solution, x equals negative square root of AB, so x equals negative square root of AB, is discarded because x is defined to be positive, just like what we stated in our first conditional. So what does that mean? X is equal to the square root of AB is the geometric mean and the answer. So let's go ahead and take a look at some examples. First, define a and b, then find the geometric mean between each pair of numbers in simplified radical form. So here I have 5 and 45. Let 5 be a, and let b be 45. So using this little formula over here, I have 5 over x is equal to x over 45. Now, if I were to cross multiply, I have x squared equal 5 times 45. And since these are whole numbers and we're dealing with simplifying the answer in simplified radical form, don't multiply the 5 and the 45. So this is where I want to go ahead and take the square root on both sides. So the square root of x squared is just x. And then we have the square root of 5 times, let's break down the 45. I'm thinking 9 times 5, okay? So x is equal to 5 times 5. Well, look, that's a pair. So I can eliminate one and bring out the other. And then this 9 here, that's under the square root. So that's the square root of 9. So that's 3. So 5 times 3 goes, those two numbers go outside. So nothing else under the square root. I'm done. X is equal to 15. X is 15. B, so it's 12 over x equals x over 15. We're going to cross multiply. So x squared equals 12 times 15. 12 and 15 are whole numbers, so don't multiply the 12 and the 15 together. Take the square root, x is equal to 4 times 3 times 3 times 5. So 4 times 3 is 12, 3 times 5 is 15. I have a pair of 3's, and then this 4 can be broken down as 2 times 2, right? So I can go ahead and highlight that. So x is equal to 2 times 3, the square root of 5. So multiply the coefficients, so x is equal to 6 root 5. Let's look at C. Okay, so I do 1/6 over x equals x over 192. Cross multiply. X squared equals 1/6 of 192. Okay, so we have a whole number multiplied by a fraction, so I'm okay with multiplying that. So x squared is equal to 1 over 6 times 192, that is 32. Now I'm going to take the square root. So x equals two numbers that multiply together give me 32, where one of them is a perfect square. 16 times 2. So x equals, okay, the square root of 16 is 4, so 4 goes outside, root 2. Similarity in right triangles. Theorem: if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. In the figure below, triangle ABC is a right triangle. Notice that there is a segment perpendicular to the hypotenuse of triangle ABC from vertex C. This creates two similar triangles, so let's split the figure so we can see the similar triangles involved clearly and then fill in the following blanks. So I'm going to redraw this. This is triangle CBN, so CBN. And then over here, this is triangle ACN. This is my small figure, this is my large figure, and then this is my medium figure. So, since these two triangles share the same angle B, we can say that they are congruent. And the fact that this segment is perpendicular to this segment, and also this segment is perpendicular to that segment, this is 90, this has to be 90. So if this is 90, then it should be the same over here. Okay? And then lastly, JK, I'm going to compare the large figure to the medium figure. So we can see that they both have a right angle. And then we can see that angle A is congruent to the angle A of the medium triangle. So I can go ahead and safely say that those two angles are congruent. So that means that, okay, we have one tick mark, sorry, not one tick mark, one arc here in a right angle, and we have one arc here in a right angle. So that means that angle C and angle A must be congruent. So I put two arcs there. Now look, we have two arcs here, one angle. So two arcs, one angle, and then that means that angle B must be congruent to angle C. That should have one arc there. So let's go ahead and fill in the blanks. We have, I'm going to do this last. We have AB over AC equals AC over blank. And this is referring to comparing the large to the medium. So we have two arcs, and then we have two arcs. So BA or AB corresponds with AC. So then AC of the larger triangle, so I'm going large first, so AC has 2 and 1. We need to find that side with 2 and 1 for the medium triangle, or from the medium triangle. So 2 to 1, we can say that that is AN. Okay, so we filled in that blank. Now over here, we're going to compare the large to the medium. Oh no, sorry, large to the small. So here's the large. So AB, we have two arcs. So 2 arcs. That must be CB or BC. And that is equal to CB over BN. Now, this one here deals with medium to small. So here's AN, here's AN, it has the right angle, 2 arcs. I'm going to find that on the smaller triangle. So right angle, 2 arcs, that is CN. So then we have blank over BN, and this is the medium, and this is the small. Okay, let's look at the small one. So the small one is BN, which is 1 arc, 1 right angle. So 1 arc, 1 right angle. CN should be up top. So triangle ABC is similar to triangle CBN, and that is also similar to triangle ACN. So this is my large, this is my small, and this is my medium. Okay, so the original figure is similar to the 2 triangles split. So a corollary describes a result from a theorem. Corollary 1, SAAS. When the altitude is drawn to the hypotenuse of a right triangle, the length of the altitude is the geometric mean between the 2 segments of the hypotenuse. Okay, so this right here is what we call the hypotenuse. And since we have a part here and a part here, and you add them up, that would be your hypotenuse. We call those parts segments. So this is segment 1 and this is segment 2. And then the non-hypotenuse, or the sides that are not the hypotenuse, we call those the legs. So since I call this segment 1 for this triangle, this over here is what we call leg 1. And then since this is segment 2 for that triangle, this has to be leg 2. And the segment that is perpendicular to the hypotenuse is what we call the altitude. So what do we say about the altitude? Well, the altitude is the geometric mean between the 2 segments of the hypotenuse. Okay? So just like over here, x is the geometric mean between A and B. So our formula is segment 1 over altitude equals altitude over segment 2. Again, the altitude is the geometric mean between S1 times S2. Or you will say the altitude is equal to the square root of segment 1 times segment 2. Okay? And we call this SAAS, our little acronym. So, let's take a look at corollary 2. When the altitude is drawn to the hypotenuse of a right triangle, each leg is the geometric mean between the hypotenuse and the segment of the hypotenuse that is adjacent to that leg. So again, what I want you to do is, where's the hypotenuse? It's over here. Essentially, I'm asking you to label. And then this is segment 1, this is segment 2, this is leg 1, this is leg 2, and then over here, this is the altitude. Okay, so what is this saying? Again, it says that each leg is the geometric mean between the hypotenuse and the segment of the hypotenuse that is adjacent to that leg. Lots of words. But really, it's saying, okay, you have, there are 2 scenarios. So number 1, hypotenuse over leg 1 equals leg 1 over S1. We call that hills, or HL1L1S1, or you might face something like this, H over L2 equals L2 over S2. We call that hills with the subnotation 2, so H over L2, L2, S2. Okay, so again, you need to make sure that the you're dealing with the same subnotations here. So the legs, so each leg is the geometric mean between the hypotenuse and the segment of that hypotenuse, and that applies to this one over here. Okay, so please, number one, label, and then know your formulas, because basically you're creating a proportion. So you have a ratio equals a ratio, ratio equals a ratio, and we already talked about similarity before, so this is not new, but this will help you. This HLLS and SAAS acronyms will help you, with these problems that we're about to do. So examples here: find x, y, and z. Label your diagrams. Number one. You may need to use an organizer to figure out which variable you need to find first, and then find the rest. And I will tell you how to do this organizer thing once we label our figure. So let's look at this figure here. Which one's the hypotenuse? This here is the hypotenuse. Okay, so this one here, this right here is the hypotenuse. And I'm actually going to define, or find the measure of the hypotenuse. The hypotenuse is actually 25 because it's 5 plus 20, so the hypotenuse is 25. Okay, that's good to know. And then here, we're going to call this 5 segment 1, because this segment plus this segment is going to give you that hypotenuse, that whole thing there. So S1 is 5, and then S2 is 20. And then these sides here are not the hypotenuse, those are my legs. And since I called this side here segment 2, you need to call this side leg 1. And over here, this is leg 2. And then the segment perpendicular to the hypotenuse is what we call the altitude A. So x is equal to A. Alright, so now what you need to do is write all of these things out. And in fact, I need to call this S1 and this is S2. Okay? So, call this S1A, A, S2. And over here we're going to call this HL1, L1, S1. And this is going to be HL2, L2, S2. Alright, so since we labeled all of this, we're going to fill these out. So what is S1? S1 is 5, and I'm going to do that for all the S1s that I see here. So here's an S1, that's 5 too. And then the altitude is x. So for all the altitudes that I see, I'm going to put x underneath each A. And then S2, segment 2, that is 20. So 20 here. Where else can I put a 20? 20 there. And let's see, the hypotenuse is 25. Then leg 1 is Z. So Z here, Z there. And then L2, L2. So leg 2 is Y. And great, I have everything now. I am going to do the problems now. Let's start with this SAAS with the segment 1 and segment 2 here. The formula is S1 over A is equal to A over S2. So you're doing 5 over X equals X over 20, and then you're going to cross multiply. So X squared equals 5 times 20. Take the square root. X equals the square root of 5 times 5 times 4. We have a pair of 5s here. That's essentially the square root of 25, so that's 5. So 5 goes outside of the square root. And x equals 5 root 4 is your answer. Now let's take a look at hills with the subnotation 1. What's the formula for that? Well, it's h over L1 equals L1 over S1. So I do 25 over z equals z over 5, cross multiply. So z squared equals 25 times 5, take the square root. So z equals, well, the square root of 25 is 5, so 5 goes outside, and 5 goes in the, or this 5 here goes inside. So z is equal to 5 root 5. And then this one, okay, it's hills with the subnotation 2. So h over L2 equals L2 over S2. 25 over y equals y over 20. So cross multiply. Got y squared equals 25 times 20. Take the square root. So we got this y equals well, the square root of 25, that's easy. 5, it's gonna be 5. 5 goes outside, so 5 root 20. This is not your answer. You gotta break down the 20 here. So y equals 5 root, let's see, 5 times 4, and 4 is a perfect square, right? So what's the square root of 4? That's 2. So y equals 5 times 2 root 5. So y equals 10 root 5. And that, did I mess up somewhere? Oh, I think I messed up somewhere. Let me try again. So we have 25 times 20. Oh no, I'm looking at the wrong part of the key. My bad. Actually, this is my answer. Yeah, that's my answer. Okay. 5 root 4. Did I have a 5 root 4 somewhere? Looking at my key. Did I mess up on the key somewhere? So 25 over z equals 5 root 5. And then that's 10 root 5. Oh, so I must... Okay, so this right here I messed up on. Because this is not 5 root 4. Y'all, this... So x equals the square root of 5 times 5, and then we have the square root of 4, right? So x equals 5 times 2, so x equals 10. There you go. That's your answer. So I didn't make any mistakes here. The only mistake that I made was this one, because I did not take into consideration of the square root of 4. So x equals 10, so you should have x equals 10, z equals 5 root 5, and then y is equal to 10 root 5. There you go. Okay. Let's do some more examples here. Again, we're going to label. So this hypotenuse, this is my hypotenuse because it's across from the 90-degree angle. So 8 plus 25, that is 33. And the two segments create that hypotenuse. So I'm going to call this segment 1, segment 2. And this must be leg 1, leg 2, and this is the altitude. So I'm going to do h, or I can just do what I did before. Segment 1, altitude, altitude, segment 2. H, L1, L1, S1. And then the other one should be H, L2, L2, S2. So segment 1 is 8, the altitude is Z, and then segment 2 is 25. And look at that, I actually can create a proportion with this. So, let's just do that right now. So it's 8 over Z equals Z over 25. So 8 over Z is equal to Z over 25. Cross multiply. So z squared equals 25 times 8. Take the square root. Z equals 5 root 8. Z equals 5 times the square root of 4 times 2. And then look, we have a perfect square here. So z equals 5 times 2 root 2. That's 10 root 2. Okay, so that's your answer for that one. And then let's figure out hills with the subnotation 1. So h is 33, L1 is x, S1 is 8, and look at that, only one variable, and it's just like this one, so we're in good hands. So 33 over x equals x over 8, so x squared equals 8 times 33. Okay, so take the square root, so x equals 4 times 2 times 11 times 3. And we know that 4 is a perfect square, and everything else, they're not. So our answer is x equals 2 root 2 times 11 is 22 times 3, that's 66. So 2 root 66 is my answer for x. And then for hills with the subnotation 2, okay, so our hypotenuse is 33, leg 2 is y, and then segment 2 is 25. And great, one variable, I can work with that. So y squared equals 25 times 33. Take the square root, y equals, okay, the square root of 25 is 5, so 5 root 33 is your answer. Okay, so now let's take a look at our last problem. Hopefully I have enough room here. So where is the hypotenuse? So this here is the hypotenuse, because this segment here and this segment here will be perpendicular. So it's the longest side too. So this is our hypotenuse. So h is equal to, well, I have x and a 9. I don't say 9x, I actually say x plus 9. So part plus part is equal to a whole. And x is segment 1, and then 9 is segment 2. This is L1, and this is L2, and then our altitude is 12. Okay, so let's go ahead and hopefully, again, I hope I have some room to do this problem. I have h, L1, L1, S1. The hypotenuse is x plus 9. L1 is y. And then S1 is x. Now notice that we cannot create a proportion with this one because we have too many variables. There's more than one variable with this, so I can't create a proportion whatsoever. So I'm going to have to find something else to work with. So segment 1, altitude, segment 2, segment 1 is x, altitude is 12, and segment 2 is 9. And how many variables are we dealing with here? 1. So I can actually work with this. So x over 12 equals 12 over 9. I cross multiply. So 9x equals 12 times 12 is 144. So x equals 16. Because 144 divided by 9 is 16. So x is equal to 16. This is wonderful. Since x is equal to 16, and look at that, there are x's here. So we can actually plug them in. That's great. That's wonderful. Let's do that right now. So we have 16 plus 9, and then we have 16 over here. The hypotenuse is 25, and then our segment 1 is 16. So I can go ahead and just create my proportion. So 25 over y equals y over 16. Cross multiply. So you have y squared equals 25 times 16. And y'all, look at that. If we take the square root, we have two perfect squares here. So y is equal to 5 times 4, which is 20. And then lastly, let's take a look at the last one here. So we did hills with the subnotation 1. Let's do hills 2. So HL2, L2, S2. Hypotenuse is 25. So the hypotenuse is 25. L2, what is L2? L2 is Y. And then segment 2 is 9. So 25 over Y equals Y over 9. So Y squared equals 25 times 9. Take the square root. We have two perfect squares again. So Y equals 5 times 3. So that is 15. Okay? So really, to approach these problems, know your hills in SAAS. That's the hard part, and then the algebra stuff you should already know how to do. The simplifying radicals is something that you should already know how to do. Okay? Looks like that I am done. Thank you.